Okay, welcome everybody. The lesson today is about 3.4, which is techniques in graphing, so I'm just going to quickly go through what you need to know. Most of the stuff you've already kind of talked about in your previous classes, like Algebra 1 or Advanced Algebra, so it should be alright. But the idea is that if we start with any function, like f of x, and let's say it looks something like this, that if we want to shift this function up or down or left or right or flip it over the x-axis or flip it over the y-axis, so if I wanted to like move it up, let's say, so now it looks like this, there's a way that we can do that. Okay, and in fact, if we just take f of x and add c to it, that would just shift everything up. Okay, and there's 6 basic rules I want you guys to know, so let's just write them all down. Okay, so if we're given a function f of x, then if we want a new function, f of x plus c, so let's just do all 6 of them, y equals f of x minus c, y equals f of x minus c, y equals f of x plus c, y equals negative f of x, and y equals f of negative x. Okay, these 6, we call these translations. Or reflections. These 6 things will do something to the original function, whatever it may be. Maybe this cubic looking graph or an absolute value or any other graph, it doesn't matter. They all work the same. As long as we have a parent function like this one, we can move it up, down, left, right, and do everything we need to do with it. So here are the rules. If we add something to the original function, it's going to go up c, whatever c is. If we subtract, it's going to go down c. If we have a minus c, x minus c, within the function, and you'll see what that looks like in a minute, that's going to move it right c. If we have f of x plus c, that'll go left c. So it's kind of easy to remember. If it's outside, it does exactly what you think it would, up, down. If it's inside the parentheses or inside the function, you do the opposite. So if we subtract, we go right, and if we add, we go left. These last 2 reflect either over the x or y-axis. If the entire function is negative, so like a minus outside of the entire function, we're going to reflect over the x-axis. If the negative is within the function, like if we see a negative x plugged in, that's going to reflect over the y-axis. Okay, so these 6 translations and reflections, you got to know them. Okay, this will make life easy for you because any graph, any function that you learn about is going to follow these principles here. Okay, it could be a cubic, a quadratic, an absolute value. We haven't even done trigonometry yet, but when we do the sine and cosine graphs, they all follow these same rules. Okay? So now here's what I also would like for you guys to know. When there are several of these, so several translations or reflections, so whenever you have several translations or reflections, there is an order that you should follow in order to obtain the correct graph. Okay, first, you're going to move left or right, depending on what the scenario is, if that's present. Second, if there's any reflections, you take care of those next. Okay, so whether it's either, if it's over x or y, do those. If you have both reflections, so if you were to have a negative on the outside and inside, that order is interchangeable, but you got to stick with this. Left or right first, any reflections next, and then third, if there's any up or down translations, we do those last. Okay, so if you stick with this order, then you're guaranteed to get all these graphs correct. Okay? Let's do an example so you can see how this stuff works. We'll do a basic one. Let's say we have a little grid here, 3 by 3, and let's say that we have a very, very easy graph starting at 1, 1, going to 3, 2, and that this segment here, this is f of x. Okay? And the question is to write out, or to graph, f of negative x plus 1 minus 2. So if we want to graph this, we're going to follow this format. So first, do we move left or right at all? Well, I'm going to look here. If there's anything in the parentheses, I know that we go, in this case, left 1, so I'm going to write that down. There's no right movement, it's just left 1 because of this plus 1 here. Next, I'll do any reflections. Well, here I see an x that's negative, so that means we are going to reflect over the y-axis. Anytime we have a negative x plugged into the function, so now we're going to reflect over y. And then last, we go up or down if there's any of that. And outside of the function here, we see that there's a shift down 2. So I'm going to do these 3 steps, and then I'll show you the final graph. So first, you just take the original function, which is f of x, and you do exactly what this says. You move everything left 1. So this point goes left 1, this point goes left 1. So after I do step 1, here's where I'm at. Okay? Now it says to reflect over y. Well, my y-axis is this one. So if I just flip this over the y-axis, this point stays right where it is. This point's going to go to negative 2. And now this is after my second step is done. The last step I have here is that I'm going to shift down 2. So now if I take every point and move it down 2 units, this purple segment, this represents a new graph that we're saying is f of negative x plus 1 minus 2, which we obtained by simply moving left 1, flipped it over the y-axis, and then we moved it down 2. So here it shows step by step what everything looked like. This purple segment here is the final graph. Okay? Now the idea is that these work for any functions. So all those nice little parent functions that you guys learned, these also work if you recognize what's going on. So I'll just do a couple examples like that. So for example, let's say I have y equals x minus 1 squared plus 1. The parent function, the one that we know about that's really related to this, is just y equals x squared. So I'm going to start with that. Okay, and I know what that looks like. If you graph the parent function, I'll do that in black. We are at 0, 0, 1, 1, and then 2, 4. So this is the original y equals x squared. Now, according to this, from what I see here, it looks like because of this minus 1 in the parentheses, that we have a shift right 1. There's no reflections. But then at the last step, we're going to go up 1. So if you follow these steps, you can take every point on the graph and simply go, so I'll start up here. Go right 1, up 1. So right 1, up 1. Take this point, go right 1, up 1. Take this point, go right 1, up 1. Take this point, go right 1, up 1. and take this point, go right and up 1. So then here's your final graph. So the shape stays the same. The only thing that happens is that everything gets shifted over right 1 unit and up 1 unit. And like I said, this works no matter what kind of functions you have. So if you recognize the parent function, then you're in good shape, because you can just follow these same rules. Okay. Let's try one more by recognition. Let's say we have f of x equals negative x cubed plus 2. Okay, so first I'm looking for left or right movement. I don't see any of that because there's no adding or subtracting within the cube, because that's the parent function. Parent function is y equals x cubed. But I see that there's a minus in front, so that means a reflection over the x-axis. And I see this 2 at the end, which means up 2. So these are the 2 steps I'm going to do. And once you get good at this, you may not have to draw the original function if you really know these shapes. But until you get there, it doesn't hurt to draw them in. 5, 6, 7, 8, 9, 10. Okay, so here's our original function, x cubed, and we want to graph negative x cubed plus 2. So if I graph, and I'll do this in black again, the normal x cubed graph, 0, 0, 1, 1, 2 is going to be 8. 1, 2, 3, 4, 5, 6, 7. So right here. Then we do the same on the left side of the graph, except it's negative 1, and negative 2, negative 8. So here's the cubic graph. And now we just follow these steps to get our final answer. If we reflect over the y-axis, over the x-axis, then this point at the origin stays where it is. This point flips across the x-axis to negative 1. This point flips up to positive 1. This point at positive 8 goes down to negative 8. And this point down at negative 8 goes up to positive 8. So now, here's what I have after doing one step. So if I flip it over the x-axis, this is what I have. My last step is to go up 2. So if I go up 2, now I just move every point up 2 units. So I'll do my final graph in red. Every point goes up 2, so this is here. This goes up 2, this goes up 2, this goes up 2, and this goes up 2. So now your final graph looks something like that. So this red graph represents f of x equals negative x cubed plus 2. You start with the parent function, which is x cubed, which is this one in black, and you do your 2 steps. You flip it over the x-axis, which is this purple one here, and then you move every point up 2, and that gives us our final graph in red. Okay? So not too hard. One more example, and then we're done with the notes here. So this is a little trickier, but this is more of just kind of recognizing what algebra is being done to a function. So let's say I start with g of x equals x squared plus 3x plus 1. And I want to know what steps or translations and reflections you can do. So let's say, what translations or reflections are there to get this new graph? Let's say f of x equals negative x squared minus 3x. Okay, so here's what I would do if I saw something like this. We don't have to graph it. I mean, obviously we can take our graphing calculator, plug that in, and you'll see what's going on. Algebraically, you can kind of see that there was a negative applied to the whole equation, because that's how we got, so let me write that down. Minus g of x equals negative x squared minus 3x minus 1. So now we're getting really close to what f of x is. Okay? However, you see that after I take the negative of the whole thing, I get a minus 1 here, and we don't want anything here. So the last thing that we can do, if I don't want this to be at negative 1, if I add 1 to both sides of the equation, now I get minus g of x plus 1 equals negative x squared minus 3x, and then these ones cancel out. So right here it tells you exactly what needed to happen in order to get from this original g of x to this new f of x. Because here it says that we did negative g of x, so what does that mean? That means we reflected over the y-axis, and then this plus 1 at the end means that the second thing we did was shift up 1. So to answer the question, what translations, reflections are there to get from here to this, to get from this original function g to this new function f, you would say if you reflect over the y-axis and you shift up 1, that's how you would get there. And you can confirm this with a graphing calculator if you want. All right, that's it for the notes. See you guys tomorrow.